In 3.1, we will be learning about congruent figures. Exciting. A very important definition that we're going to need to write down will be congruent polygons. Now, polygons are sided figures like triangles, squares, octagons, hexagons, heptagons, whatever. And they are congruent if all their corresponding parts are also congruent, meaning their sides and their angles. So in this first example here, you don't really have to write it down. What I'd like you to do is maybe pause the video and think, okay, what two triangles are congruent? And then we'll have the answer there. For our first set of triangles, we want to point out that it's very important that your angles and your sides match up. So this angle A here should match up with angle D. Notice the congruent marks right here and here are the same. So I'll have triangle A, and I'll have triangle here, it'll be starting with D, and then I have B is the next one that matches up with R, so we have B and R, and then I have C and S have the same congruent marks, so we have C and S. So these two triangles are congruent. And you won't really have to pay as much attention to it later because you're going to get really good at it, but you do have to make sure that your angles and sides all match up. Notice how if I look at side AB, it should match up with side DR. AB has one tick mark, DR has one tick mark. Very, very important. And that would work with BC, RS, and then AC and DS as well. So you really have to make sure that you're writing it in the correct order. Next one. We have our two triangles. So we have triangle, let's see here how we start with NML is congruent to triangle, and let's see here. If we have N right here, which had 3, we also have to go with N once again. And then if we went to M, which has 2, we go to P, and then lastly we'll have Q. And there's our two congruent triangles. And when the orientation gets flipped around, it gets a little trickier and trickier as we go. So let's just start out with writing down a triangle. So let's say triangle A, B, C. Next thing we'll do is we'll match it up with its corresponding angles. So if I have A has one tick mark, which angle has one tick mark? D has one tick mark. So we have D right here. And then we'll have two tick marks for B, because angle B right here is two tick marks, and then C is the next point that will match up with that. And then B over here will match up with C over here. And there you go. And we can even check the segments too, like we did before. Let's see, how about BC should match up with CB. BC and CB both have 3 tick marks. AC has 1 tick mark. DB has 1 tick mark. We're good. This next property is called a reflexive property, and a lot of people think, oh, it's just really common sense. And yeah, it is. But we do need to use it in our proofs. It is important in our proofs at times, and we'll see some examples of that soon. So any segment or angle is congruent to itself. Yeah, common sense. So if you have line segment BC, it's going to be congruent to line segment BC. Our next example, if we have triangle DEF is congruent to GHI, which segment is congruent to EF? So which one's congruent to EF? The way I like to look at this, and feel free to pause this and try these on your own, EF would match up with HI, so it would be segment HI. Now, next one says which angle is congruent to HIG. If we're looking at HIG, think about the angle's vertex. So we're looking at HIG, so I would be our vertex. So that means that angle EFD would be our congruent angle. EFD. And see how you have HI and then G? EF, and then D. So it was in the same order. The order is very, very important when we're talking about triangles. Which segment is congruent to GI? Well, let's see here. GI. If I have GI, those are the first and last. Same will be here. D and F. So segment DF. And is FE congruent to HI? Let's see here. Is FE congruent to HI? Well, EF, FE, that's the same thing, right? So yes. You could write it as EF, you could write it as FE, it still means the same thing. So EF and HI are the last two written down there in the triangle, so yes, they are congruent. In this problem, we're going to plot some points, P, S, and T, and then we're going to shift them 3 units down and 2 units to the right to find our new points. So let's start by plotting them. So here I have P, S, and T all plotted on my XY coordinate plane. We should all know how to plot points. Should be good there. Now, it says if triangle STP, so this triangle here, is shifted 3 units down and 2 units to the right, find the coordinates of P prime, S prime, and T prime. So let's shift these 3 units down and 2 units to the right. So if I go 3 units down and 2 units to the right for P, I have P prime right here. And if I go 3 units and 2 to the right for S, I'm right here. So I have S prime here. And then T prime, 3 down and 2 to the right, I'm out here. So my coordinates for P prime would be, let's see here, -2, -3. S prime would be 5, 2. And T prime would be 7, -3. So here I have my new triangle, which has been shifted 3 units down and 2 units to the right. This next one here is the same set of points, but this time we're going to reflect them over the x-axis. Ooh, that's fun. So let's get our 3 main points on the graph. Now that we have our 3 points, let's get the next ones. We're reflecting over the x-axis. Remember, if we're reflecting over the x-axis, that's this guy right here. Well, if I'm going to reflect P over the x-axis, it really actually doesn't even move. Let's reflect S over the x-axis, and it moves all the way down here. So my S prime will be right here. My P prime will actually stay where P was, and same with T prime. T prime is going to stay put as well. But we'll see another example where we reflect over the y-axis, and it's a little bit different. So there's my new triangle, and my new points are as follows. Notice how P prime and T prime have stayed the same, but S prime is a little bit different. We have a -5 with my S prime now, because I reflected over the x-axis, which has moved it vertically and changed my y-coordinate. In this last example, we're reflecting over the y-axis. We need to write our coordinates of P prime, S prime, and T prime. So we're going to reflect this triangle here over the y-axis this time. So if we do that, if I switch P over the y-axis, I'm going from here all the way over to the other side, which would be right here. So I'm going to have P prime right there. For S prime, if we're reflecting over the y-axis, I'm going to end up over here. See, it's kind of like a mirror. There's my S prime. And then T prime is going to be all the way over on the other side right here. And then here's my new triangle, which has been reflected over the y-axis. Let's write down those points. Notice this time all my x-coordinates have changed. So all these x-coordinates have changed sign. Since I'm reflecting over the y-axis, I'm moving horizontally with these points, which is changing my x-coordinate. Kind of opposite of what you think when you reflect over the y-axis, but your x-coordinates change. For this example, we're going to rotate clockwise 180 degrees, and there's a little trick for rotating 180 degrees. We're going to switch both signs of the coordinates. So we're going to have 4, and then you can't really switch the sign of 0, so we just get 0, which puts me at this spot here. For the S, I'm going to have -3, -5. So I'm going to be right over here for my S prime. And lastly, T prime is going to be -5, 0. So P prime and T prime are very similar to the reflecting over the y-axis. However, the 180-degree rotation is different. It's just because they're on the x-axis that happens, and that's a similarity. But that's not how it's always going to be. Notice how my S was completely different from any of the other ones that I did. One thing you will notice is that if you have a point starting in quadrant 1 over here, it'll end up in quadrant 3 over here with a 180-degree rotation. If I start in quadrant 2 over here, I'll end up in quadrant 4 over here. If I start in quadrant 3 right here, I'll end up in 1, and so on and so forth. Here's our homework. Our quiz will not be Thursday, it will be Tuesday.